Now we have here f of x is mapped onto 2x minus 3 divided by x plus 1. G of x is x plus 2. G is mapped onto x plus 2. Right? Should be g of x is mapped onto x plus 2. Evaluate f of 2 and g f of negative 2 and g f of negative 2. So here, part 1, f of negative 2. Rewriting it this way, f of x is 2x minus 3 divided by x plus 1. But we want f of negative 2. So f of negative 2 means we're going to remove the x and put negative 2 there. So that's f of negative 2. 2 times x becomes 2 times negative 2. This x plus 1 becomes negative 2 plus 1 because we are finding f of negative 2. 2 times negative 2 is negative 4. Negative 4 minus 3 divided by negative 2 plus 1 is negative 1. So what we have is negative 4 minus 3 is negative 7 divided by negative 1. Negative 7 divided by negative 1 is equal to positive 7. Alright. So we have 7 for the first answer here. The next thing now, we want to find gf of negative 2. Now, rewriting it here, we want gf of negative 2. So, we already found f of negative 2 a while ago. The fact that you have this means that whatever this is, you're finding g of it. You're finding g of that thing. Now, just like how if you are asked to find g of, say, 5, when you have g of x would be x plus 2. Remember, g of x is x plus 2. If you are finding g of 5, it will be 5 plus 2. So that would give you 7. Now here, g of f of x negative 2. F of negative 2 is 7. So this is equal to 7. So you're going to put 7 into g. So in that case now, what you're really finding is g of 7. Because f of negative 2 is 7. You're finding g of that. So it's g of 7 you're finding. So you put 7. You put 7 into g. So therefore, g, we see g here is x plus 2. So g of 7, g of f of negative 2 is g of 7, which is 7 plus 2, and that gives you 9. So the other answer here that we want, what we wanted to find is 9. Good. Now, here, determine f inverse of x. So that's part 2. We must determine f inverse of x. So part 2 here says we want f inverse of x. We want to write back f of x down here. F of x is 2x minus 3 over x plus 1. Right? It is 2x minus 3 divided by x plus 1. These things are too close. Let me just remove these further out to the right. Now, what we have here is f of x is 2x minus 3 divided by x plus 1, and we need f inverse of x. Now, when finding the inverse of this function, we remember step 1. We change f of x to y. So what we have here is y equals 2x minus 3 divided by x plus 1. Good. We're finding f inverse of x. Then we remember step 2. What we do is change x to y and y to x. That's what we do here. So in this case, we say x is equal to 2y minus 3 divided by y plus 1. Then we go to step 4. Step 4. You're going to transpose. You're going to make y the subject. Make y the subject of this equation. The thing now is this. This part is going to be usually the most difficult part. The transposition, rewriting it to make y the subject, is almost always the most difficult part of the inverse, finding the inverse. Here, what we have is x is equal to 2y minus 3 divided by y plus 1. Let me make some space between the x and so on and so forth. Remember, you want to have the main aim in making y the subject is to have y equal. Nothing else must be mixed up with the y. Everything else can mix up themselves together one on the other side. But y alone must be here. Right? So, we can, what the aim now is to get two y's beside one another and factorize. Right now we have one y over the other y. It's not going to be so easy to deal with this. You can't factorize the 2y and the y here. So what we do, multiply both sides by y plus 1. Suppose we do that. Multiply this by y plus 1. We have to multiply this by y plus 1. In fact, the reason why you multiply the right hand side by y plus 1 is to get rid of the y plus 1. Now, what you have here is x multiplied by the y plus 1 equals 2y minus 3. Now, with that move, you can get the y's together. So you have one y. You need to have only one y and no more y's. So if you multiply x times y, you're going to get xy, and you multiply x times 1, you're going to get x1, which is just x, equals 2y minus 3. Now, you see that when you have two y's to transpose for, it's much harder than when you have just one y. The reason why this transposition is so complicated is because you started out with two y's and you want to transpose to make one y equal, right? So you have a lot of mixing up and all sort of things to do. But then Notice at some point we can take this xy and this 2y and put them together. You can't just rub this out and put it over here now. You have to move them in the right way. So let's see, how do you get this 2y on the left hand side? What you do here is to subtract 2y from the right hand side, and it's going over to the left. So what you have here is xy plus x equals 2y minus 3. Suppose you subtract 2y. You have minus 2y. You minus 2y on the right, you must also minus 2y on the left. Look at this. 2y minus 2y is 0. So what you have here is xy plus x minus 2y equals, this is gone, you know. So you have, the only thing you have here now is negative 3. Alright. The thing is, we want to get rid of this x. It would make life a lot easier if we get rid of this x from over here. So therefore, what you can do is subtract x. If you have here, you have xy plus x minus 2y equal negative 3. If you subtract x, you're going to have minus x on the left and minus x on the right. This is out, you know. That's out, that's gone. So you have xy minus 2y equals negative 3 minus x. And then here you have 1y now. You can get 1y. Y. Then you have x minus 2 equals negative 3 minus x. You see that? Then if you just divide by x minus 2, divide both sides by x minus 2, you would have xy times x minus 2.
I'm sorry, sir, I'm sorry.
Equal negative 3 minus x. Alright. Then what you do here, divide by x minus 2. The x minus 2 on the left hand side is gone, and you have only y. Only y you're going to have equal. So we're getting there, getting near to the goal. The thing is, you divide the left hand side by x minus 2, you must divide the right hand side by x minus 2 too. So guess what happened now? You have negative 3 minus x divided by x minus 2. Oh, you see that most of the work is involved in this transposition when you're doing inverse function. You will find in many cases the transposition. That transposition part is the hardest, right? But if you're in an exam, even if you transpose and you do foolishness in the transposition, you don't really lose a lot of marks, because you're not being your skill at transposition is not what is being tested here. Your knowledge at how to transpose is not what is being tested. What is being tested is your knowledge of inverse function. It's just that a transposition is part of that inverse function business. So here, the last step that you take now, let's call it step, how many steps we had again? We had 4 steps. Step 5, the last step in the transposition. Step 5, you're going to change y to, and it's going to be f inverse of So what you have is f inverse of x equals negative 3 minus x over x minus 2. Alright, we have this thing, negative 3 minus x over x minus 2. We have to write it down up here now. Negative 3 minus x over x minus 2. Let's write it down up here. So we have negative 3 minus x over x plus 2. Alright, so you see the amount of work and the fact that the transposition x minus 2, that amount of work, let me even forget that it is x minus 2 instead of x plus 2, right? The transposition part, man. Alright, after that now, alright, let me label this properly. F inverse of x equals, after that part we have f of x, find x so that f of x is 0 and also f of x is undefined. Now, the fact is, you're being asked to find the value of x for which f of x is 0. What you have for f of x equals 2x minus 3 over x plus 1. Alright. When f of x is 0, it simply means that this is 0. And you're going to find out what the value of x is. Now, you can just remove this f of x part. You don't really need that part anymore. When this is 0, there are certain steps you can take. Let me move the 0 and the equal sign over a bit. Here, what you can do is multiply both sides by x plus 1. If you multiply by x plus 1 and multiply this by x plus 1, what you have, x plus 1 cancel x plus 1. And then you have 2x minus 3 equals 0 times anything gives you 0, right? It's going to be 0 here. Then you want to find out what x is, so you want to write x equal, x alone equals. So you get rid of this negative 3 and this 2 that mix up with the x. Or you get rid of the negative 3. If you add 3, you're going to get 2x minus 3 equals 0. Just add 3 over here. Negative 3 plus 3 is 0, so all you have is 2x. Alright? But you added 3 to the left. We have to add 3 to the right as well. 0 plus 3 is 3. So what we have is 2x equals 3. Good. After that, we still don't have x alone. We have the 2 mixed up with the x. We need to get rid of that 2. What you need to do is to divide by 2. So 2x equals 3. You must divide by 2. When you divide by 2, you now have the x alone equal. And then here, you must divide the 3 by 2 as well. So what you have here is 3 divided by 2. Good. So that is the value of x when you have f of x equals 0. You just write down f of x, write the equals 0, and then you do your calculation. Now, the next part, part B of 3, says calculate the value of x for which f of x is undefined. Alright. That part. This was 3a here. Let's do part 3b here. Now, f of x was 2x minus 3 over x plus 1, right? Now the thing is this. When f of x is undefined, when you have an undefined function, you remember in that case you are trying to divide by 0. And it cannot work. You cannot divide by 0. So that function is undefined. So in order to make this function undefined, you look at what is under here and make it equal to 0. Right? When you make that equal to 0, then you say x plus 1 equals 0. That's what's going to happen when the function is undefined. You're putting something up here over 0. Right? Because look at this. If you make that equal to 0 now, what you would be trying to do is make 2x minus 3 over 0, which is undefined. It can't work. So when you do that, you are saying x plus 1 equals 0, because what is under here is x plus 1. And if you make it 0. So in that case, x plus 1 is 0. What could x be? Well, we know that negative 1 plus 1 gives you 0. So x has to be negative 1. Right? Or you could consider that when you have x plus 1 equals 0, if you subtract 1 from both sides, x plus 1 minus 1 is equal to 0 minus 1. So x would be negative 1. In any case, you're going to have x being equal to negative 1 in that case. So that's that.